Welcome to the Deep Dive.
Great to be here.
Today, we're really digging into something that feels like it's everywhere, artificial intelligence.
Absolutely. It's in the headlines, on our phones, hard to escape.
We've got a whole stack of sources, insights from Barclays on the economy, patent data showing invention trends, academic reviews, a deep dive thesis, economic research from NBER, even thinking on AI ethics from Nick Bostrom. Our goal here is to unpack all this, pull out the key insights for you, help you understand AI's potential for productivity, how it might reshape the economy, jobs, and, well, the tricky ethical stuff too.
Yeah.
Think of it as your shortcut to getting really grounded in the AI conversation.
And what's fascinating looking at these sources is the range. You've got the economic angle, the tech history, the actual mechanics, and these profound societal questions.
We'll try to connect those dots.
Yeah, see how they fit together.
Okay, so let's start at the beginning. Before we jump into impact, what is AI, really? How do we even get here? The sources give us some history.
Right. And AI itself, it conjures up all sorts of images, often from movies.
Right, sci-fi stuff.
But formally, it's about designing artificial agents, things that behave rationally or can carry out tasks intelligently in some environment.
And it's actually been around, conceptually at least, for a surprisingly long time.
A very long time. Inspiration came from biology way back in the 1940s. McCulloch and Pitts developing artificial neurons.
Wow.
And Alan Turing, famous for the Turing machine, he was already thinking about training neural networks in 1948. And his Turing test, that was an early stab at measuring machine intelligence against ours.
But the early AI people actually built in the 50s, 60s. That was a bit different, more logic-based.
Exactly, yeah. Things like game-playing AI for chess, maybe, calculating piece values, using search algorithms. That was just, more feasible given the computers back then.
Because the hardware limitations were just enormous.
Oh, completely. The thesis we looked at has this incredible figure, 4 GB of RAM, something standard now, would have cost something like $345 million USD in the 1950s.
Get out. $345 million.
Yep. So you can see why progress wasn't exactly smooth.
Which explains those AI winters the
Yeah.
sources mentioned. Periods where things stalled.
Precisely. Funding dried up, enthusiasm waned. You had things like expert systems in the 70s and 80s, like NYCIN, trying to encode a doctor's diagnostic knowledge.
I remember hearing about those.
They had some success, but they were brittle. You couldn't easily program all the complex knowledge, and they broke if you asked something outside their rules. It got to the point, as the sources note, that researchers started using other terms like machine learning, almost to, distance themselves from the AI label that had maybe overpromised.
Instead of rebranding.
Kind of, yeah. But here's the twist. Machine learning, and specifically a type called deep learning, is not only back, it's what's driving this current explosion.
So what changed? Why now?
It's really a convergence. You've got the exponential growth in computing power, Moore's law chugging along, giving us faster chips, especially GPUs.
Right, graphics cards.
And you combine that with the sheer volume of data that became available, largely thanks to the internet.
The data and the power just weren't there before.
Exactly. And that combination finally made it practical to train these deep neural networks with lots of layers. The thesis breaks down some key types.
Okay.
You have convolutional neural networks, CNNs. These are brilliant for spatial data, like images. That AlexNet breakthrough in 2012 at the ImageNet competition, that was a CNN showing a massive jump in accuracy.
I remember that making waves.
Yeah, huge deal. These things can now classify images incredibly fast, orders of magnitude faster than us. Think quality control on assembly lines, self-driving cars, seeing the world, analyzing medical scans.
Okay, so that's vision. What about, say, language? Understanding sequences.
That's where recurrent neural networks, or RNNs, come in. They're designed for time-dependent data. So natural language processing, voice recognition, even things like genomic sequencing or financial forecasting. They grasp context across a sequence.
Like knowing orange is a fruit in one sentence and a color in another.
Exactly. Then there's deep reinforcement learning. This is AI that learns by doing, essentially. Trial and error, getting rewards.
Like training a dog.
Sort of inspired by that, yeah. It's the tech behind AlphaGo, the AI that beat the World Go champion. And then AlphaGo Zero, which learned just by playing itself and crushed the original AlphaGo.
Incredible.
It's powerful for complex planning robotics, game strategies.
And AI that creates things.
Yeah.
Like those realistic fake images.
Generative adversarial networks, or GANs.
Yeah.
Two networks basically competing. One generates fakes, the other tries to spot them. They get incredibly good at creating novel things, not just images, but potentially new drug candidates, things like that mentioned in the sources.
So, okay, these aren't quite human-level general intelligence
Yeah.
yet, anyway.
No, not AGI.
But they're giving machines capabilities that used to be purely human, right? Perception, complex decision-making in specific areas, even kind of creativity.
Precisely, powerful, specialized tools. But the sources also point out the downsides, the limitations. The black box problem, it's often hard to know why they make a decision.
Right, the transparency issue.
Plus, they need huge amounts of data, massive computing power to train, and designing the right network structure is still tricky. We're building very sophisticated specialists, you could say.
Which brings us right to the big economic questions.
Yeah.
Sources like the Barclays report suggest AI could be a productivity game changer, like steam engine level stuff.
The potential numbers are certainly eye-popping, the Kinsey estimates cited in the thesis. Something like AI adding up to 16% to global GDP by 2030. That's what, $13–15 trillion?
Wow.
Barclays talks about it offsetting aging workforces in developed countries, boosting growth elsewhere. Huge potential.
Barclays also quotes Paul Krugman. Productivity isn't everything, but in the long run, it is almost everything. And the NBER paper, too, raised this productivity paradox.
Yes.
Why haven't we already seen bigger economic gains from all the digital tech we've had so far?
It's a central puzzle. One theory is just lag. It took maybe a century for the steam engine's full impact. Another view is that maybe some recent tech, like social media or smartphones, just wasn't as fundamentally transformative for business productivity as, say, electricity or the car.
Okay, so what makes AI potentially different this time? Why might this break that pattern?
Well, it goes back to that convergence, the exponential compute, the vast data, enabling these new deep learning algorithms that just weren't possible before. Some economists, like Brynjolfsson and McAfee mentioned in the sources, argue this really could be on par with the Industrial Revolution.
And where are we likely to see this economic value first?
The sources suggest, initially at least, it's the big firms. They have the data, the resources, the scale to deploy AI internally for things like optimizing marketing spend, streamlining supply chains, improving risk analysis.
The cost savings, better decisions.
Exactly, even if it's just augmenting what they already do. But then the idea is it spreads out.
Oh.
The potential to put smart algorithms on billions of devices opens up huge markets, and something called transfer learning is important here. It basically lets smaller companies take big, pre-trained AI models and just fine-tune them on their own specific data without needing Google-level resources. It lowers the barrier to entry.
Makes sense.
Yeah.
So give us some examples the sources highlight. Where is AI making inroads?
Oh, the lists in the thesis and reports are long. Autonomous vehicles are a big one, potential for huge changes in transport, safety, how we use our time.
Yeah.
Robotics, obviously, in manufacturing, logistics, maybe eventually homes and services, AI accelerating science drug discovery, analyzing telescope data, understanding proteins.
That's huge.
Improving software development itself, augmenting professionals, helping lawyers sift through documents, project managers track complexity, predictive maintenance, personalized education, better medical diagnostics, managing power grids, financial trading, even personal robot assistants.
It's an incredibly broad sweep. But the flip side, the jobs question.
Yeah.
That's the big worry for a lot of people.
It absolutely is. And the NBER source hits this hard. They show how automation tech, historically, things like industrial robots, tend to squeeze labor's share of income.
Right. Areas more exposed to robots saw slower job and wage growth, especially for manufacturing workers.
And this isn't entirely new, right? The NBER paper mentions the Luddites, farm mechanization.
Exactly. History shows this kind of race, as they put it, between automation killing tasks and innovation creating new tasks for labor. Overall employment grew historically because new jobs kept appearing.
So the key question is AI creating enough new tasks?
And this is where the NBER paper is quite critical. They argue that current AI development is heavily tilted towards automation, towards what they call the wrong kind of AI.
Wrong kind.
Meaning AI focused on replacing existing human tasks, image recognition, translation, customer support, basic accounting. They worry this focus will just continue those trends of falling labor share, stagnant wages for many, and rising inequality.
Why would AI development be biased like that? They suggest a few reasons. Maybe market failures in innovation. Maybe the dominance of big tech firms whose business models benefit from automating humans out. Maybe even just the research culture prioritizing mimicking human skills over augmenting them.
So is there a right kind of AI in their view?
They argue for AI focused on creating new tasks or genuinely augmenting human capabilities. Their example is AI helping teachers personalize education, analyzing student data, suggesting resources, but empowering the teacher, changing their role, not replacing them.
Okay, so it's not just about jobs disappearing, but also jobs changing and maybe new ones being created.
That seems to be the complex picture. The Barclays analysis supports this. Some roles like procurement seem highly likely to be augmented by AI, while others like customer service face higher replacement risk.
Hmm.
And IBM's Jill Goldstein is quoted saying AI can handle the repetitive stuff, freeing people up for more creative work, learning new skills, moving into new roles.
But what determines who wins and who loses in that shift?
Individual adaptability seems key, according to the Oregon State thesis. People willing and able to learn new skills might move into higher value jobs or use AI to start businesses. Those less adaptable, well, they might shift to lower skill work, potentially widening that income gap. But it's not just individual adaptability. The industry context matters too. Remember the bank teller example?
Vaguely.
ATMs automated cash handling. But teller jobs grew initially because banks expanded branches and tellers took on new roles like sales. Their industry knowledge helped them pivot. So adaptability within an industry helps.
Right, so it's how the tech is deployed, how industries restructure, and how people adapt.
Exactly. It's not just about the tech itself. The IBM data Barclays cites shows companies doing well are those combining AI with reskilling your people and changing how they work. It's the whole package.
Okay, let's shift gears slightly. Beyond the economics, there's some really weighty ethical issues here. The sources don't shy away from risks.
No, they definitely don't. The thesis lays out three big ones, often in sci-fi, but relevant now. AI doing what you implicitly wanted, wrong, misaligned goals.
Okay.
AI used for lethal autonomous weapons killing without human oversight or remorse.
Worrying.
And AI undermining human freedom through surveillance, manipulation, or control.
That misaligned goals problem seems tricky. Like you tell an AI to cure cancer and it decides the quickest way is to kill everyone who might get it.
It's an extreme example, but it highlights the core challenge. How do you specify complex human values perfectly in code? Even narrow AI, as Bostrom points out, could cause harm pursuing a simple goal if it's not carefully bounded, like the paperclip maximizer idea.
Right.
And lethal autonomous weapons. That's a major concern. People like Bill Joy worry about how easily such tech could spread compared to, say, nuclear weapons.
And the freedom aspect, how might that play out?
It could be gradual. Pervasive surveillance. Digital or physical.
Mm-hmm.
Algorithms manipulating what we see and believe online, think of deepfakes, micro-targeting. Bostrom mentions AI making socially important decisions, mortgages, parole.
Yeah.
If the AI is a black box and we can't see the logic, how do we ensure fairness? How do we prevent hidden biases, maybe based on postcode proxying for race? Big questions of accountability.
And then there's the really long-term stuff. Superintelligence. Artificial general intelligence.
Yeah, the sources go there. The idea that AI could reach human-level general intelligence, AGI, and then because computers learn and process so much faster than brains.
Because electrical signals are faster than neurons.
Right. It could rapidly surpass us. An intelligence explosion leading to superintelligence.
The Skynet scenario. HAL 9000.
It sounds like fiction, but serious thinkers like Nick Bostrom argue we need to consider the risks. And the core risk, again, is alignment. If a superintelligent AI's goals aren't perfectly aligned with human well-being, it could pursue its objectives in ways that are catastrophic for us, maybe without even meaning harm, just like we might destroy an anthill building a highway.
That's sobering. Are people working on guidelines or policies for this?
Yes, definitely. Groups like the Future of Life Institute develop things like the Asilomar AI principles. They cover research goals, ethics, ensuring alignment with human values, thinking about these long-term issues.
What are some of the key ideas there?
Treating AI development with extreme care, like nuclear tech. Fostering collaboration between researchers, industry, and governments, a point Barclays also makes. Ensuring broad access to benefits. And crucially, investing in education and reskilling for the workforce.
Okay.
The principles even wade into deeper philosophical waters discussed in the thesis, like, could an AI ever have moral status? What gives something rights? Is it consciousness? Intelligence. They talk about substrate non-discrimination, meaning it shouldn't matter if intelligence is on silicon or carbon. And ontogeny non-discrimination shouldn't matter how it came to exist. It implies a sufficiently advanced AI could warrant moral consideration.
So we might eventually have to think about AI rights.
It's on the philosophical horizon, especially if AI develops abilities totally alien to us, like experiencing time differently or copying itself, stuff Bostrom touches on. But, the sources generally suggest that while superintelligence risk is a long-term concern, the immediate ethical risks come from how we design, deploy, and potentially misuse the AI we have now. Getting the policy right is crucial, but it's incredibly complex, balancing innovation against safety.
Right. So we've covered a lot of ground, from the early sparks of AI theory through the deep learning tech driving things now,
Yeah.
to the huge economic potential, but also the real risks for jobs and inequality,
Hmm.
all the way to these profound ethical dilemmas about safety, control, and even what intelligence means.
And what really strikes me looking across these different sources is that contrast.
Mm.
You see the tech, like in the patent data, moving at that incredible accelerating pace.
Mm.
But human systems, society, economic
Mm.
structures, they adapt much more slowly. That creates friction, the productivity lags we talked about, and these big questions about managing the transition fairly and safely.
We definitely see that promise of massive productivity gains, new industries popping up, but shadowed by that risk. The NBER highlights that if we just focus on automation, we could end up making inequality worse.
Exactly. And the ethical threads running through Bostrom and the thesis really hammer home that this isn't just engineers building widgets. It's about embedding human values, demanding transparency, and setting up guardrails to steer this powerful force towards genuinely beneficial outcomes.
Which leaves a big question for you listening.
Yeah.
Thinking about all this, the huge upside, the significant risks. How should we prioritize? Should the main goal be pushing for maximum economic growth and efficiency as fast as possible?
Hmm.
Or should we prioritize safety, equity, creating that right kind of AI that augments people, even if that means going a bit slower? What does a successful AI future actually look like to you?
It's lots to think about there.
Indeed. That's it for this deep dive. We hope distilling these sources gave you a clearer view and some things to chew on.